Example 3. Graph each function, compare the graph to the graph of the parent function, which are the 4 functions that we just went over with the horizontal asymptote, and then describe the domain and range of f. So, example A, in order to graph this, we're first going to start by making a table. I'm going to have x, I'm going to have f of x, and the values I'm going to use here, I'm going to use -2, -1, 0, 1, 2, and we're just going to see what happens. So starting out, I'm going to substitute the -2 in for the x. So we're going to have -2 times 4 to the power of -2. Grab your calculator, substitute that in, and we're going to get -1/8. Or if you're using a calculator that's going to give you a decimal, it's the same thing as saying -0.125. It doesn't matter which one you're using. So -2, -1/8 is just about there. We're going to do the same thing with -1. So -2 times 4 to the power of -1, which is going to give us -1/2, or again, -0.5. Then I'm going to substitute in 0, so -2 times 4 to the 0, which is -2. Then 1, which is going to give us -8. And at this point, I'm kind of going off my graph, so 5, 6, 7, 8. And then just for fun, I know I'm already off my graph, but I'm going to substitute in the 2 anyway, which is going to give me -32. And there's no way I'm getting that on my graph. But if I kind of look at what's going on here, I can see the shape forming. And if I go back and compare that to one of my parent functions, it looks to me like this is going to follow in the, if I look at my b value, the growth category, where watch my pen would technically go up, but because the a value is negative, instead of going up, it's actually going to reflect over the x-axis, and it's still going to come small over here, but then go down. Now, before I actually draw this, I'm going to consider my horizontal asymptote. So I'm going to use my dotted pink line. This guy is never actually going to get to 0. So when I graph this, I don't want to touch that line. So I know it's going to come out like that. Don't actually touch the pink. And then curve. And then it's going to get really, really, really steep. So your graph's going to look something like that. Now, describe the domain and range. So I'm going to start with domain. Keep in mind, domain is all of your x values from left to right. If I grab my highlighter, going left to right, okay, if I follow it out, I'm touching the black line there, I'm touching the black line there, I'm touching, and it has an arrow on it, so my domain is going to go to -infinity. As I come the other direction, I'm touching my black line, okay, and if I come out here, I'm not technically touching it, but you have to consider that this has an arrow on it, and even though it gets really, really, really steep, it's still going out to the right. This is at 0, this is at 1. At 2, we're down here at -32. If we substituted 3, we'd have a value. 4, we'd have a value. So it's still going. It's just getting really steep. So your domain, the whole way left to the whole way right. So all real numbers. Or you can say -infinity to infinity. Now, range. Keep in mind, your range is low to high. So I'm going to start low. Okay, if I go low, 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 I'm highlighting, the arrow goes the whole way down. So -infinity. Now, as I'm coming up, it's at -4, it's at -3, it's at -2, it's at -1. It's at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115 -1/2, -1/8, -1/16. And this is that idea that it's getting smaller and smaller and smaller, or getting close to 0. It's getting close to right there, that pink line, that horizontal asymptote, but it's never going to touch it. So our range starts at -infinity, and I'm going to use a parenthesis because you can't actually touch infinity, and comes up to 0, but never touches 0, so parenthesis. Now, that's if we want to write it in interval notation, or we could just say y is less than 0. That would also be acceptable, but make sure you do not put the equal to sign because it never actually touches 0. Letter C. Okay, so I'm going across the page, not down the page. I'm going to start the same way. X, f of x. I'm still going to do -2, -1, 0, 1, 2. Okay, this time I'm going to take the -2. I'm going to go substitute it in. I'll let you kind of figure that out on your own, but when you do that, you get 32. So -2, 32, definitely not fitting on my graph. Then I'm going to substitute in -1, which is going to give me 8. So -1, 8, I can pretend and put that up there. 0 is going to get me 2. 1, when I substitute in, is going to get me 0.5. And then 2, when I substitute in, is going to get me 0.125, which is even smaller. And at this point, I think I have a good enough picture of what's happening. So this one, definitely kind of coming down. This is more of your decay. Okay, so it starts big and gets smaller and smaller and smaller, but never, looks to me, again, going to reach 0. That's where my asymptote's going to be. So then I'm going to connect. And that would be my rough graph. So if I was going to compare this one, I'd probably say because of the 1/4, that number is between 0 and 1, which is less than 1. So this is your decay, or going down. And then because this is positive, it's going to be above the x-axis. It's not going to be reflected over. So that's kind of what's going on and what we can expect to see. Now, domain and range. Domain is left to right. Okay, if I follow this graph, it's going at 2, 1, 0, -1, it did have a value, -2, it did have a value. If I keep going, it's still going to have values the whole way out because of our arrow, though it gets very steep. All real numbers. Range, low to high. So the question here is, well, how low does it go? Well, I have my asymptote. It kind of goes to 0, but doesn't touch it. And then how high does it go? Well, that's got an arrow on it. That's going to go forever. So I'm going to say y is greater than 0. It's at 0 and going bigger, but it doesn't actually touch. So don't put the equal to. Letter B. Now, before we actually graph this one, let's make a guess at what's going to happen. Okay, so the first thing I'm looking at is right there. Is that going to be the growth where it comes up, or is that going to be the decay where it comes down? And the first thing I'm thinking is because, okay, that's a fraction that's small, I'm thinking probably decay, which leaves us with the blue one. So I'm thinking it looks something like the blue one. Now, the next thing I'm looking at is the negative. So if it's negative, it's going to be above the x-axis, like the one I just drew, or is it going to flip and go below the x-axis, like the red one? Well, based on the fact that that's a negative, I'm going to say it's going to be below or reflected to kind of like flip down. So my ultimate guess before I actually plot any points is that my graph is going to look like that. So let's see how we did. So -2, -1, 0, 1, 2. We're substituting in values. So if we substitute in -2, we're going to get -16. Once again, that's going to be way down here somewhere. It's not going to fit on my graph. If I substitute in -1, I'll get -4. If I substitute in 0, I'm going to get -1. If I substitute in 1, I'm going to get -0.25, which is -1/4. If I substitute in 2, I'm going to get -0.0625, which is even smaller. And then I'm going to compare and say, okay, I thought that it was going to start down and kind of come up. Well, it does. It starts down here and comes up. Keep in mind your horizontal asymptote here. So we're not going to touch 0. And then I'm going to trace my green. Don't touch 0. And we were pretty close. So the green one is the actual graph. The red one was my guess. So ultimately erase the red one and don't pay attention to it. And then we're going to do domain and range. So domain, left to right. Goes the whole way right. Keeps coming out left, although it does get steep, all real numbers. And in fact, you're going to catch on to this, but what is the domain all the time of an exponential function? It's always all real numbers, -infinity to infinity. Range, low to high. So this one is below the x-axis. So it goes the whole way down to -infinity and then kind of comes up and approaches 0. So y is less than 0. Letter D. Okay, once again, before we graph anything, let's make a guess. If I'm looking at my 3 is your common ratio. So that's a whole number. It's greater than 1. So are we thinking the growth or are we thinking the decay? I'm thinking probably I'm going to go with the growth one because it's getting bigger. So probably more like the blue one there. Then I'm looking at my A value, and this guy, I don't really see an A value. It's kind of missing, which means there's a positive 1 there. So because it's positive, it could either be above or below the x-axis. Well, because it's positive, I'm guessing it's probably above, like that blue one. So my rough guess would be that this graph looks something like that. Let's try. X, f of x. -2, -1, 0, 1, 2. If I substitute in a -2, I'm going to get 0.111. So -2, about right there. Substitute in -1, 0.333, which is just a little bit bigger. Substitute in 0, you get 1. Substitute in 1, you get 3. Substitute in 2, you get 9, which goes pretty far off our graph. And then consider this guy looks to be approaching 0 still. And he's going to go something like that. Okay, so same idea. Domain, all real numbers, goes the whole way left, goes the whole way right. Range, he is above the x-axis, so y is greater than 0.